Hi everyone, these videos tutorials are regarding physics and physical quantities. This specific video regards electrical variables and electrical formulas. I decided to use Python because the end goal of my videos will be to create softwares that make use of the formulas that we pretty much all know in order to create then softwares. But in this video I will just present some basic electrical quantities and electrical formulas. So let's start. Of course, everybody knows V stands for voltage and is the tension, E stands for current and is the ampere, resistance is the amount of heat that is generated once the current then flows inside some materials, conductance is the opposite to resistance, impedance is the total between resistance and reactance is the opposition of like the resistance, but not it doesn't generate heat, but it creates magnetism of or capacitance. Maybe we will come back to it later on. Then there is capacitance, which is measured in farad and basically is regards batteries. Inductance is the ability to create magnetic fields. And then there is the electric charge, which is in coulomb. Okay, so taken this 10, 12 electric variables, I want to split them in the formulas that are most commonly used. Right now I'm not even creating functions, so basically using Python is not useful, but then we will convert it into functions. So P is the instant power, is the power of V multiplied by I. Conductance, as I said, is the opposite of resistance. Coming to something interesting, the resistive power is the amount of power transformed in heat by a resistor. So it means that if we have power and we have current and tension, we can calculate how much heat is generated inside our resistor, inside our wire. If we have the resistance, we can power up the current and then multiply it by the resistance, or power up the tension and divide by the resistance. Coming to AC voltage formulas, as we all know, AC is a sinusoid, so it has a peak, but what we actually care is not the peak, it's mean square root, which we can calculate it taking the peak voltage or peak current and divide it by the square root of 2. Since we are talking about AC current and we said that we have a mean square root, we must remember about active power and reactive power. So active power is the multiplication of the 2 mean square root of voltage and current multiplied by the cos phi, which is a number that you will have, and basically it will be between 95 and 90, 0.9 and 0.95. Reactive power is calculated differently. We can take the tension power up to 2 and divide it by the resistance. This we will come here. Anyway, the apparent power is the sum of the 2 and is just the multiplication of the tension and the current. This little reminder, active power and reactive power, the motors that has to spin a lot probably require much reactive power than active power. Reactive power is not something bad, is something that is necessary to start up many machines, but sometimes our provider and distributors doesn't like that we ask for reactive powers, so generally a higher cos phi is the best choice, is a better choice for industry. Then reactance, which we talked and we have seen here, is similar to but not equal to resistance. It can be further explored into inductive reactance and capacitive reactance. One is in advance to the tension, in advance to the sinusoid, and the other is in retard. It doesn't, I don't even know which one is what, and I don't want to talk too much about it. These are the two formulas, which are quite complicated. What is mostly important here is that we are talking about a frequency, which basically if we improve the frequency, one is going faster and the other is going slower, but all this reminds us that of course the frequency must remain constant. So in fact the frequency of our in Europe is 50 Hertz and in America is 60 Hertz, and you must not change it, otherwise the machine will face problems. Moving on, impedance is the total of resistance and reactance, as we already said, but is a complex number, meaning that actually we don't care if it's a complex number, we only need its magnitude, which is at the end of the day equal to the square root of the resistance at the power of 2 plus the reactance at the power of 2. This impedance, which is important in many fields, like when you want to make the grounding of systems, can be also used if you have the tension but don't have the current or the opposite, and you have the impedance. You can calculate the other one in alternate current. Admittance is not useful. Then coming to Coulomb. Coulomb is measured as ampere per second divided by second. Actually, ampere per second. So basically, it links the current is the amount of current that flows in 1 second of time. No, actually, this formula is wrong, is 1 divided by S. So in how much current flows in 1 second or in 2 seconds, etc. This formula is what explains most what Coulomb is, but actually is what's most important is this one, because it's a formula that we use with batteries. So we have the capacity multiplied by the tension, and here we have another formula which we always use with capacity, which is the energy, which is the capacity multiplied by the tension at the power of 2. So these two formulas might be a little subtle because we don't really understand intuitively understand the energy and the Coulomb. The difference is, if you look at the formulas, is that the energy is exponentially proportioned to the power of the tension, and this is linearly proportional to the tension. And here it comes the fact that the Coulomb is the energy multiplied by the tension. Actually, is what I'm said is wrong. Is the Coulomb that is the energy is the Coulomb multiplied by the tension, and when we use what, for example, I'm giving a simple example. If we want to know how much the battery will last if we consume a determined amount of watt, what we are actually going to use is E, the energy. How much charge the battery has, we use Q. Okay, so this was the first lesson. In the next lessons, we will also talk about other things that other physical variables and physical formulas, and then further on I will end up using Python to generate some functions for softwares.